Hey there, MSM3. We are back again for more exponent rules, and my paper keeps wanting to fly away. It's not going to, though. I will keep it in check. All right, so exponent rules part 2. We only have one new rule to learn today, which means it's probably a biggie, right? It's one new rule, and it has big overall implications. We're going to use it a lot. We're going to call it distribution, and it's not like distribution that you've done before where you have a number on the front left on the outside and you distribute it to everything on the inside. This is exponent distribution. So we've got AB to the second. What does it mean? It really means that we're doing A to the second and B to the second. The reason that happens is because this is multiplication on the inside. The other distribution that you guys are used to had addition or subtraction on the inside. This does not. This has multiplication with an exponent. When the product of numbers is raised to an exponent, the exponent is distributed to all factors, and then the individual quantities are multiplied. So that is fancy for there's multiplication on the inside, and we're going to use the exponent on all of the parts being multiplied. So 3 times 2 inside brackets being raised to the second power, that's the same as 3 to the second times 2 to the second. Same idea. If you have a 1 times negative 1 and all of it is being raised to the second power, that's the same as 1 to the second times the negative 1 to the second. And you'll notice I kept my parentheses there because of the negative 1. I don't want this to look like subtraction. I could have done it on the first one as well. I could do 3 to the second times 2 to the second, and that would work the same. Now, the reason we have this rule is really for the variables, because I could do 1 times negative 1 and then raise it to the second. I could do 3 times 2 and raise it to the second. But I can't multiply x times y because I don't know what they're worth. So I can do x to the fourth, and I can do y to the fourth, and they're still multiplied because it was originally multiplication. This one, I would say there's a 2 on the outside, everything multiplied, 1 to the second, 4 to the second, 3 to the second. So that's what I'm distributing. I'm distributing the exponent to everything that's being multiplied inside the brackets. A to the second to the fourth gives us an a to the eighth. So when you have an exponent raised to another power, the exponent should be multiplied. Now that's really important, and that's where the most sort of important part of this comes in. An exponent raised to another exponent, you multiply them. So x to the second, we're actually going to do 2 times 2, or x to the fourth. 3 to the second to the fourth, we're actually going to do 2 times 4, which is 3 to the eighth. 2 to the second, okay, well, that's going to be 2 to the fourth. 1 to the second, that's going to be 1 to the fourth. And 4 to the second is going to become 4 to the fourth. Every exponent inside, I multiplied it by the 2, the power it was being raised to on the outside. This, every individual piece on the inside, negative 7 being raised to the second, 3 being raised to the second, and negative 1 being raised to the second. Since nothing on the inside had an exponent, it's really 1 times 2, 1 times 2, 1 times 2. The last one here, because it is variables, this is really where we're applying it. A has a 1. 1 times 6 would be a to the sixth. B to the second raised to the sixth, if I multiply the exponents, b to the 12th. C to the third to the sixth, if I multiply the exponents, c to the 18th. So I'm just going to do a number of examples down here at the bottom so we get a little bit of practice. You can still do the highlighting if there is any combining to happen. So this one does not have any exponents outside the parentheses. I've got a 6 and a 4. They are both coefficients with no variable. They can get multiplied. I've got n to the 8th and n to the 4th. They can get multiplied. And I've got m to the 6th, m to the 6th. They can get multiplied. So 6 times 4 is 24. N to the 8th times n to the 4th. They are being multiplied, so I'm going to add their exponents, n to the 12th. M to the 6th, m to the 6th. They are being multiplied, so I'm going to add their exponents, m to the 12th. Next, 4 times 5. Now, if you don't need the highlighter, you don't have to. It's just a strategy. And I've also got an a to the negative third, a to the 9th. So I'm multiplying 4 times 5, which is 20. A to the negative third, a to the 9th. If I add those exponents together, I get a to the 6th. Negative 8 times 3, those are my coefficients, the numbers out in front of the variables. I'm also going to do x to the second times x. I'm also going to do y times y. This gives us a chance to practice what happens if there are no exponents. And z to the 7th, z to the 5th. Now this one looks a little bit messier just because there's so much color going on. So negative 8 times 3, that's negative 24. X to the 2nd times x is really a 2 plus 1, x to the 3rd. Y times y, that's a y to the 1st, y to the 1st. If I add those exponents together, y to the 2nd. Z to the 7th, z to the 5th. If I add those exponents together, 7 plus 5, z to the 12th. All right. Now we've got the ones that have the exponents. So we've got 10 being raised to the 2nd power. So 10 times 10 is 100. Y to the 7th being raised to the 2nd power. Y, 7 times 2 is to the 14th. Now you'll notice that is being multiplied by a second term. So I'm going to put that second term in parentheses. Negative 2 to the 3rd. Negative 2 times negative 2 times negative 2 is negative 8. And y to the 3rd. So now I have a second step. I've simplified two terms, each being raised to an exponent. And now I've got to do 100 times negative 8. And I've got to do y to the 14th times y to the 3rd, y to the 17th when I add the exponents together. Anything raised to the 0 power is 1. I don't have to do any other simplifying on the inside. All of this stuff inside, regardless of what it is being raised to the 0 power. It is just worth 1. Now we've got w to the 6th being raised to the negative 3rd. I'm going to multiply those exponents, w to the negative 18th. And then I've got 4, no exponent, w to the 3rd, no exponent. So I'm going to copy that. Only did the exponent on the left first. Now I have no number out here in front of the w. So I'm getting 4 as my coefficient. W to the negative 18th times w to the 3rd is w, add the exponents together to the negative 15th. Now here's where that rule from the last lesson about negative exponents comes in. I can drop this w to the negative 15th into the denominator. If I change the negative 15th to its opposite, positive 15, the 4 does not have an exponent, so it just stays in the numerator. All right, let's see here. 7 to the 2nd would be 49, and k to the 15th to the 2nd, if I multiply the exponents, is k to the 30th. What's great is this whole second term being raised to the 0, it's just worth 1. So we would multiply, right? 49k to the 3rd times 1, it's just 49k to the 30th. 30th, I think I said 3rd. 15 times 2 is to the 30th. All right, now I can take out those highlighters again. I've got a 10 over a 5. They're both coefficients. I've got an x to the 9th over x to the 6th. I've got, there's another one down there, x to the negative 2nd. So that's going to give me a little bit of an extra step there. And w to the negative 3rd, sorry, w, y to the negative 3rd, y to the 5th. So 10 over 5 is 2. But when I go to do the second simplifying, I've got this extra piece down here in the bottom. So I might simplify the 10 over 5 to 2. I've got an x to the 9th, which I'm not simplifying yet. X to the 6th, x to the negative 2nd is x to the 4th. I added the exponents together. And I've got a y to the negative 3rd, y to the 5th. And I have to simplify the x to the 9th over x to the 4th. They have a common base. So I'm going to have 2, x to the 9 take away 4, x to the 5th. And then I've got y, negative 3, take away 5. Ruh-roh. Negative 3 plus negative 5 is going to be negative 8. And you'll notice that I've got that exponent with a negative, and we really don't want that. So the better way to write this one would be 2x to the 5th over, I'm going to drop the y to the negative 8 into the denominator and change the exponent to its opposite, positive 8. Change my marker color just to make this last one a little easier to see. I can distribute that 3 to the numerator and the denominator the same way I distributed that exponent 3 to a first term and a second term. So 5 to the 3rd, 5 times 5 times 5 is 125. X to the 2nd to the 3rd, if I multiply the 2 times 3, is x to the 6th. Then in the denominator, y to the 5th, also raised to the 3rd, y 5 times 3 to the 15th. And since there's only x's in the numerator and y's in the denominator, that one would be done. There's nothing left to simplify. All right, hopefully you come with lots of questions. See you in class.